For number 64, we are to solve what mass of ammonium chloride must be added to 250 milliliters of water to give a solution with pH 4.85. The Kb of NH3 is equal to 1.8 times 10 to the negative fifth. So, from this equation, we know that Kw is equal to Ka times Kb. To the negative fifth x, and then we go ahead and divide 1.8 times 10 to the negative fifth, and that gives us x is equal to 5.56 times 10 to the negative 10. From that, we know ammonium hydrolyzes so therefore we are given the equation NH4 plus H2O NH3 plus H3O plus. We know that the pH gives H3 and NH3. Therefore, we know that H3O plus is equal to 10 to the negative pH. So we can go ahead and do 10 to the negative 4.85, and that goes ahead and gives you the answer of 1.41254 times 10 to the fifth. To the negative fifth. From that, we go ahead and use the Ka formula to get NH4. So then we go ahead and plug in the numbers. 5.56 times 10 to the negative 10 is equal to 1.41254 times 10 to the negative fifth times 1.41254 times 10 to the negative fifth divided by x. From this, we are able to see that x is equal to 0.358867. So then we go ahead and put 250 milliliters into liters, which is 0.250 liters. From that, we go ahead and divide those two numbers, 0.358867 divided by 0.25, and that gives you 0.0897165. You go ahead and multiply that number times 43, which is the molar mass of H4Cl. And that gives you 4.75. And 4.75 is our final answer. For problem number 61, we need to calculate the pH of a 0.14 molarity of HNO2 solution, that is 5.7 ionized. We're able to go ahead and break down HNO2 into this equation. From this equation, we know that it's a 1-to-1 ratio. So we can go ahead and do 0.14 times 5.7 divided by 100. This is 0.14 times 0.057. And if you go ahead and plug this into a calculator, we go ahead and get 0.00798, which is also equal to, if we go ahead and round it, 8.0 times 10 to the negative third. And that gives us our final answer. For number 68, we need to calculate the pH of a 3.5 times 10 to the negative third molarity of HNO3 solution. So we know that H is equal to 3.5 times 10 to the negative third. pH is equal to negative log of 3.5 times 10 to the negative third. And if we go ahead and plug this into a calculator, we go ahead and see that the pH is equal to 2.46, which gives us our final answer. Number 73, we are given two acids, and they would like to know which acid is stronger. The main difference between these two is that there is an extra oxygen on H3AsO4. Since it has an extra oxygen, it is the stronger acid. The extra oxygen atoms draw away electron density due to their electron negativity, making surrounding atoms more positive, which makes it easier for them to release protons. Because of that, H3AsO4 is the stronger acid.